on with our non-right angle triangle trig, we can use the sine rule, or a part of the sine rule, to find the area of a triangle. So we use this when we don't have a right angle, or we can't see a right angle in my triangle. Because the normal way you've been able to find the area of any triangle is to know it's half the height times the base, and that's when the height and the base have an angle of 90 degrees. So here is a formula that we can use. Area equals half AB sine C. So what that really means is we need two sides and the angle that is between the two sides. And that's the most important fact. The angle must be between the two sides. So this formula lives on in your formula booklet. So let's have a look at using it in practice. So we know the formula is a half AB sine C. So area is going to be a half times the two sides, and it's the sine of the included angle, so the angle that the two sides make when they meet. And we put it into our calculators, we get 18.00051. So therefore the area is 18.0 centimetres squared. Now you do need to have units in this case because we're finding area, and I do believe that you will be penalised in the exam if you don't put them in. So that's how easy it is. Here's another one, angle, two sides on either side, so area is a half times 10 times 17 times sine of the angle. And we pop it all in our calculator, we get 83.9535. So therefore the area is 84.0 meters squared to three significant figures. So remembering that we're always rounding to those three sig figs. Another question, same thing, area equals a half times the two sides and sine of the included angle. And we place it in our calculator, we get, in this case, 38.667 and some numbers. Therefore, area is 38.7 centimetres squared to three significant figures. And that's how easy it is to use it. So once we've mastered the easy questions, what we need to do is we need to be able to use it in more difficult questions. Now in this question here it says find the area of ABCD. So ABCD is this whole shape here. But we can see that this shape is made up of two triangles. So we're made up of triangle ABD and triangle BCD. So let's find first the area of triangle ABD. We've got triangle ABD. We know that this angle here is 61 and we've got the two included sides. So we're going to say that is a half times 18 times 11 times sine 61 degrees. And that gives me 86.587 and some numbers. So now what I'm going to do is I'm going to look at finding the area of triangle BCD. Now, the problem is I don't know what this angle is in here. I've got two sides and this would be my included angle. But I'm told that this is 90. So if I did 90 take away 61, I'd get this angle in here and that's 29 degrees. So now I've got a half times 11 times 12 and I know that the sine is 29 degrees. So let's pop that in and put a time sign here. So we work that one out on our calculators. We get 31.9974 and some numbers. So therefore the area of ABCD must be my two parts that I've gotten added together. And you need all the calculator because you don't want to make any rounding mistakes. The only time we want to round is in our very last step. So in this case we get 119 meters squared to three significant figures. And that's it. And here's another one. Find the area of this shape. Well, looks to me like we have a kite because we've got 2 equal sides and 2 equal sides. So I'm going to draw a diagonal in, and I'm going to find the first area and the second area. So if I'm finding area 1, it's going to be a half times, now these two sides are the same, so it's 60 by 60 by sine 71 degrees. And when I work that one out, I get 1,701.9334. And if I work out now area 2, it's a half times 95, and the other side is exactly the same, 95. And now we've got sine of 50 degrees. So that is 3,456.7755 and some numbers. So area 1 plus area 2 is me adding, or you adding, both of the areas together and keeping all the numbers in your calculator. You get 5158.708 and some numbers. So therefore the area is 5,150, 3 significant figures. So 1, 2, 3 is my significant figures. So that's 5160 centimetres squared to 3 significant figures. And that's how easy it is. I'm sure you're not going to have any problems, but if you do, you can ask me in class.